All right, here is a stoichiometry problem where it is asking us how many grams of oxygen are produced when 75 grams of potassium chlorate decomposes. So this is the equation that we're going to use, and the first thing that we always do is we're going to balance it. So my oxygens aren't balanced, so I'm going to make both oxygens 6 by adding a 2 here and a 3 here. And when I do that, now I need to go back and add a 2 in front of my potassium chloride so that everything is equal and balanced. This problem starts with us trying to figure out how much oxygen we need, how many grams of oxygen are coming from 75.0 grams of KClO3. So this conversion is going to have to go from grams to moles, grams of this to moles, moles to moles, and then moles to grams. This is kind of a 3-step conversion. We're going to get this all set up into one nice conversion chart so we can just go ahead and plug our numbers in and see what we get. So we're going to start with 75.0 grams of KClO3, and we need to get that into moles. So when we go from grams to moles, we need to know the molar mass. And the molar mass of KClO3 is going to end up being 121.5453. So when you add all of their separate masses up, we know that we end up with 122.5453 grams per 1 mole of KClO3. So my grams are going to cancel there. And now I've moved on to my moles. So if I have moles of one substance, I can compare it to moles of another substance using the mole ratio. I just have to make sure I write my numbers. I don't flip anything around. I want to take whatever number comes in front of KClO3, which for this case is a 2. So I have 2 moles of KClO3. And I want to compare that to 3 moles of oxygen. And then moles will cancel out. So now if I have moles of oxygen, I can convert that to grams of oxygen by finding, once again, the molar mass. For every 1 mole of oxygen, that's equal to 31.998 grams of oxygen. And now I can put this into my calculator. I'm going to want to write the top numbers in parentheses. So 75.0 times 3 times 31.998. And I just eliminated this one because it's not going to affect my calculations at all. And then I'm going to divide by 122.5453 times 2. And give me a second while I plug that into my calculator. I'm going to get my answer, and then the last thing I'm going to do is round for significant figures. And my significant figures I'm going to look at are these 3 that I started with. So I started with 3, I need to end with 3. So I get a total of 29.4 grams of oxygen. So if I start with 75 grams and it breaks down into its parts, I can make 29.4 grams of oxygen gas.